Okay, so we left off today looking at ethanol and we had a look at its structure. We said it had two properties based on its structure. We said the hydrocarbon section of ethanol, which we can actually now refer to as the ethyl group, where we know that eth is talking about the two carbons that are present that only have single bonds between them, so two carbons. And the ul is talking about the covalently bonded side group or group or section of the molecule. So this particular section, covalently bonded to this section, we refer to as the ethyl group, okay, or the hydrocarbon section if you like. We said that the OH side group, we all are now aware that we call that the hydroxyl group of ethanol. So when we drew our Perspex rod, hopefully everybody's drawn the little positive charges that would be present because we've rubbed off some of the electrons onto the silk rod, and we've drawn ethanol in such an orientation where it's attracting to the positive Perspex rod. So that would be with the oxygen end being most attracted to the Perspex rod. So you might draw it like what you can see here. So where the oxygen is attracted to the Perspex rod. So we say that ethanol has a dual nature, and that's in terms of its ability to then interact with other substances. So we know the ethyl group will form dispersion forces with other substances that it interacts with in terms of intermolecular forces. The hydroxyl group is able to form the strongest type of intermolecular force, hydrogen bond. So we're able to form two types of different dispersion forces. And what else we know, hopefully from prelim, from our water topic, is that solubility is based on the formation of intermolecular forces. So in order for substances to dissolve, they need to have some sort of intermolecular forces between the two different molecules or substances. So that's important. If we look at our universal solvent, which is water, we know that it is only polar in nature. It's got two OH bonds between the oxygen and the two hydrogens. The only possibility is for water to be polar. It's got one side that's delta negative and one side that's delta positive where the hydrogens are. So as a result of this, we know that it can dissolve other polar substances, okay, through intermolecular forces. It can also dissolve ionic substances pretty well because of the difference in the charges, okay, where the negative ions will attract the hydrogen and the positive ions will attract the oxygen. However, it will not be able to dissolve non-polar substances. Okay, not going to happen because the dispersion forces in the non-polar substances will remain and water will fail to form any intermolecular forces between that particular non-polar substance. For example, oil, okay, big, massive hydrocarbon. Remember, we have the notation for hydrocarbons, which is our zigzag, okay, so many, many carbons within, all bonded together within oil. Another example is our example from today, hexane. Because of the nature of hexane, it can only form dispersion forces. It will not be able to dissolve in water. Okay, and that's something that you're going to be testing tomorrow. So when substances can dissolve in one another, we call them miscible, able to dissolve in one another. So polar substances and ionic substances are miscible in polar water, whereas non-polar substances, for example oil and hexane, will be immiscible in water. So now we're going to have a look at the use of ethanol as a solvent. How good is it? How useful is it as a solvent? So if we look at its structure, once again, we reiterate, it's got the twofold structure. It's got the ethyl non-polar group. It's got the hydroxyl polar group. So if we're going to dissolve, for example, water and ethanol together, then you would hopefully think that it's the hydroxyl group that's going to form the intermolecular forces between ethanol and water. So we'd have water, the delta negative oxygen, hopefully, attracting to our delta positive hydrogen. And that would be one hydrogen bond. Over here, we'd have another water molecule, it's a negative, with its delta positive hydrogen attracting to the delta negative oxygen of the ethanol. So water and ethanol, due to its ability to form intermolecular forces, we would say that these two are miscible within one another. If we then have a look at hexane, on the other hand, it's got our 6 carbons all single bonded together, filled in with the hydrogens. Okay. We would then be aware, hopefully, that it's not going to be able to form hydrogen bonds. So that kind of rules out an intermolecular force with the hydroxyl group. So let's have a look at the ethyl group. Also single bonded carbons with one another, with the hydrogen surrounding it. So we know it's going to form dispersion forces. So it's the ethyl group here in ethanol that will be able to form intermolecular forces with the hexane. So if we were to draw that, we just simply, an ethanol would rearrange itself so that the polar group is nowhere near the hexane, and we would have a, if you like, dispersion force or dispersion forces between the molecules. Okay, in this instance, I'll just draw a little line to show that we are aware that there would be dispersion forces there. So because of the, again, ability to form dispersion forces, we say these two substances are miscible. So all in all, although our water is known as our universal solvent, ethanol too can be used as a versatile solvent. We sometimes use that kind of adjective because it can dissolve both polar and non-polar substances. So leading into homework for tonight, you're going to plan a little investigation for tomorrow's lesson where you'll be adding various substances to ethanol, and you will be then having a look at whether or not they're miscible and thinking about what is in the ethanol structure, what part of the ethanol structure allows that substance to dissolve. Or in the case of insolubility, why did it not dissolve in ethanol? Okay, so just have a look at the Google Classroom for that particular investigation plan. Thanks, everyone.